Alright, it's going to be our next note, lesson 7.5 on chapter 7. We've been going over similar parts of triangles or similar triangles. Now we're going to relate that to parallel lines and proportional parts formed by those parallel lines. And we're going to look at some theorems and some converses and just kind of go over that in these notes, and then I'll make some short videos showing you how to solve some of these problems, and then we'll see if you want to go over any of those in class as well. You have that option as well. So this is lesson 7.5, parallel lines and proportional parts. The first thing we want to look at is this triangle proportionality theorem, and this is our main idea for this chapter, and then we kind of build off of it for the other ideas. So this theorem says if a line is parallel to one side of a triangle and intersects the other two sides, it divides the sides into segments of proportional lengths. So and you can see here it forms equivalent ratios. So what that kind of means is, so if you have this BE here and it's parallel to the other part of the triangle CD, then we know that if we compare the two sides of the triangle, like AB and BC as ratios, that they will compare and have the same ratio as AE and ED. Okay, so that's good to know whenever we're looking at a triangle and we want to figure out for an unknown. So just keep that triangle proportionality theorem in mind. It has to be proportional, and we know, if this line is parallel to that, then it's going to be the same distance. It's going to intersect this next side, CD, equally. So that's kind of how it works. If we look at a converse of that, they're really just saying the same thing but in a different way. And it says if a line intersects two sides of a triangle into proportional segments, then the line is parallel to the third side of the triangle. So let's say we have a triangle like this. We don't know if they're parallel, but then we check and do the ratios between AB and BC. And then we compare that to AE and ED, and we see that they're the same ratio. We can then say that those lines are parallel. So that's kind of the converse of it. It's kind of looking at it the opposite way. So that's kind of the first one we want to look at, the triangle proportionality theorem. So let's add some more here. This is one we kind of started doing vocabulary, and this is the mid-segment of a triangle. This is the idea that so first of all, what's a mid-segment? So a mid-segment is a segment with endpoints that are the midpoints of two sides of the triangle. So here we have a triangle A, B, C, and then we have three of these segments here. We have our Q, okay, and it goes from one side of the triangle to the other, and you see here these where it intersects, it's like a bisector almost, where these two segments are equal to each other and these two segments, and you have every triangle has three of these. Okay, so this one ABC has RQ, it has QP, and it has RP. Okay, so it's almost like an upside down triangle, and that's the mid segment of a triangle. So whenever we see this, we know that if it is a mid segment, that it will cut each of these sides that it's running to into equal sides that are equal to each other or congruent. Okay, and then because of that idea, what a mid segment of a triangle is, we then have a theorem that works for that as well. So in this theorem for the triangle mid-segment theorem, it says a mid-segment is parallel to one side of the triangle and its length is 1/2 the length of that side. And if you remember, we did the trapezoid mid-segment theorem. This is kind of the same idea. So if we know these are mid-segments, okay, like right here, right, this is your mid-segment, and it runs from one side of the triangle to the other. And here we'd be looking this one right here, we can just figure out from that theorem that this one is parallel, okay, and that its length, because it cuts these two in half, this length JK would be 1/2 of this total length. This length JK would be 1/2 of the segment that it's parallel to, because it's cutting these into halves. Okay, so that's important to remember for that theorem. We keep going. Then we have some proportional parts. We're going to kind of tie these into parallel lines and transversals. So we have these transversals here, and this is always important to remember how we can use this for triangles. These are at certain angles, and eventually you'd see that if we just drew this out here, we'd see that they're a triangle, right, if we kept going. And there's a corollary, kind of a rule that goes with this. for proportional parts and parallel lines. And this one says, if 3 or more parallel lines intersect 2 transversals, then they cut off the transversals proportionally. Okay, so we know that, so if we have this line and it's parallel to, so line AE is parallel to BF and CG, they're all parallel, then we know that these are all, they all have some kind of proportion in relationship to each other. Now, the proportion would be this side to that side, so we'd have AB right here, and BC would be equal to EF and FG, and then again that only goes if they're parallel. If they're not parallel, it doesn't go at all. Okay, so we can use that to also help us figure out parts of triangles that we don't know. Our last rule we're going to look at is congruent parts of parallel lines, another rule that we need to remember. And here you can see we have these 3 parallel lines, and then when they're parallel, and we know that A is congruent with B, you have these slash lines here, then that can help us figure something out about this side. Okay, and this rule says if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. There should be no S there. Every transversal. So when we look at that, that really tells us if AE is parallel to BF, okay, and BF is parallel to CG, then they're all parallel, and AB, this right here, is congruent with BC, then we can assume that EF, over here, is congruent with FG. And that's kind of something you want to add to your notes as well and keep in mind. So then these are the kind of rules you want to remember again. Let me just go over them really quick. This is your triangle proportionality theorem. You know that these will be proportional sides to each other, and we can make a ratio out of them. We have the converse of that, okay, that if we have a line that intersects 2 sides of a triangle and we can make their ratios or proportions, we figure out they're equal to each other, then we know the lines are parallel. That's that one. And then the mid-segment of a triangle, every triangle has these where we can draw lines from one side to the other, intersects 2 sides, and that line cuts those sides into congruent or equal pieces. Every triangle has 3 of those, and then the theorem for that is, if that is true, so if a mid-segment is parallel to one side of the triangle, and its length is then 1/2 of that side. So if we have a mid-segment here, then we know that the lines are parallel. So to the side it's opposite. So if we have this JK here, we know it's parallel to FG. And then we also know that JK is 1/2 of FG. And that's something from trapezoids, if you remember as well. And then we have these proportional parts. So we know if we have these lines cutting through transversals, and I added that, remember, but we cut these off, and they're parallel, then we know these sides, AB and BC, are equal to EF, FG. Okay, and then the last one again is this idea of congruent parts of parallel lines. So if we have these parallel lines, and AB is these are congruent to each other, then we can say that EF is congruent to FG as well, even if they don't say they are. Okay, they have to be. If these are congruent, these are congruent. That's your notes and to your notebook. See you in class.